Have you ever wondered about the structure of thiophene? This intriguing molecule, with its humble formula of C4H4S, is a fascinating study in chemistry, featuring a blend of carbon, hydrogen, and sulfur atoms arranged in a unique pattern. Thiophene is a heterocyclic compound, meaning it contains a ring structure that is not solely composed of carbon atoms, but also includes a different type of atom, in this case, sulfur. The ring structure of thiophene is planar, which means it's flat, much like a ring you'd wear on your finger. The carbon and sulfur atoms in thiophene are sp2 hybridized. Hybridization refers to the mixing of atomic orbitals to form new orbitals that are identical. In this case, each atom mixes its single 2s orbital with two 2p orbitals to form three new sp2 hybridized orbitals. Each of the sp2 hybridized orbitals of sulfur contains one electron. Similarly, the two sp2 hybridized orbitals of each carbon atom also each contain one electron. However, there's more to the story. The third sp2 hybridized orbital of sulfur contains a lone pair of electrons. This is a pair of valence electrons that are not shared with another atom. On the other hand, each sp2 hybridized carbon atom forms two sigma bonds with its neighboring atoms and one pi bond with a hydrogen atom. A sigma bond is a type of covalent bond that forms when two atomic orbitals overlap, while a pi bond is a type of covalent bond that forms when parallel orbitals overlap, creating a bond that is weaker than a sigma bond. The unhybridized p orbital of sulfur, which contains two electrons, along with the unhybridized orbitals of each carbon atom, which each contain one electron, form a delocalized electron cloud above and below the pentagonal ring of thiophene. This delocalized electron cloud contributes to the stability of the molecule. In summary, thiophene is a heterocyclic compound with a planar structure. It is composed of carbon and sulfur atoms that are sp2 hybridized. The sulfur atom in thiophene contains a lone pair of electrons in one of its sp2 hybridized orbitals, and the unhybridized p orbital of sulfur forms a delocalized electron cloud with the unhybridized orbitals of the carbon atoms. Each carbon atom in thiophene forms two sigma bonds with its neighboring atoms and one pi bond with a hydrogen atom. The structure of thiophene is a beautiful example of the intricacies of molecular geometry and bonding.